Still not. There we go. There we are, Bruno.
Perfect. So as we said, hello everyone. Bruno here. I'm with Ivana. Do you want to introduce yourself?
Sure. So Ivana, Microsoft MVP, thanks to Bruno who nominated me MVP in AI specifically. But I'm also working, as Bruno said, working a little bit on mixed reality with HoloLens and Azure Kinect. I work for 3XM Group as a quality manager. So there you have my contact information. So that's it.
Amazing. And here, Bruno Capuano. You can find me online in Twitter at El Bruno. Also, I'm a Microsoft MVP in AI. And I basically love technology. I love to learn new things, play around things, and try to figure out how to solve problems. I always start with this, and this is me. Please do not attach this to Ivana, but you are going to see a lot of.
We can say it both of us.
And this is mostly me. I am the guy who is learning, so this is my disclaimer at the beginning. And it all started when I've been doing a lot in the last couple of years, doing a lot of face detection, face recognition, emotion detection, a lot of different activities, also object detection. And it's a nice part because you can do all of these things. A long time ago, you really need to know a lot of machine learning and deep learning things to do this kind of stuff. Today, we have tools that can help us to get there, to build these frameworks, to build these models, to detect objects. This is a test that I did last year to detect HoloLens 1. So you can do all of these things, but there is a moment that basically you realize that, hey, you can do much more. So in these crazy days that we are living, in example, it's not just about detecting someone, detecting a person. You can, if you know the plane that you are working, you can track distance, you can have some crazy calculus there, and you can define, oh my God, we are not doing social distance at home. By the way, this is my little daughter. You are going to see maybe a couple of pictures of her and my son. This is my test people right now in these days, but you can do this kind of thing. We cannot do this kind of things. The problem is when you start to try to get into a deeper level. All of the things that I just show is basically models that you can download and use. With 20 lines of code, you can detect person or faces or do these kind of things. But if you want to create your own model, you need to go deeper and learn something like deep learning. And I'm not going to go deep here on how it works. This is not the idea. But when you start to learn deep learning, you can start with an example, a photo of a dog. This is a dog, and this is amazing, a crazy and cute Chihuahua. We see this. But for a computer, it's completely different. What we have here is an array of numbers. And if we are doing a BGI formatting example, each one of the pixels is 3 numbers for the blue, green, and red. So everything that we try to do here is all around numbers. It's so big that when we start to do a deep learning process to detect dogs, for example, the first step will be precise this. We probably need to add a second step, a second layer to start to basically identify the corners and the borders, then in this one, the eyes and the nose. At the end, what we have here is an amazing model to detect Chihuahuas or muffin. And this is a freaking old job, but it's very complicated to do this kind of thing. I think I'm doing this job for the last 2 or 3 years. Sorry about this, but it's tricky to create. If you don't know the stuff, and you are learning and you want to do these kind of things, it's very tricky to create image recognition models. Lucky for us, we know the ABC. We know how this works. And the ABC machine learning is, you have your data. Once you have your data, you choose an algorithm, you train a model, and then you can use your model. This is the simple ABC. This is machine learning in 10 seconds. Sorry for the smart guys who are in the call right now. But if you know this, try to do this with a specific set of tools. It's complicated until you get to custom vision. Customvision.ai. Custom vision is part of the community services. It allows us to create our own models, our own image recognition models, and it has the ABC of machine learning. You are going to upload and tag your images, you're going to train a model, and then you're going to be able to use the training model. So it's the only thing that you need to do is how to upload images. And we talk about this for the example, what we did, and you are going to see a couple of pictures here. I upload 30 pictures of the Canada flag and another 30 of the Argentinian flag. Remember, I was born and raised in Argentina, I live in Spain, now in Canada. I put my pictures here. I also have a couple of Ivanas. And the only thing that I need to do once I upload this picture is to start to tag this picture. I basically select, this is a flag, this is a Canada flag, or this is, oops, I missed one of the demos there. This is a Canada flag, or this is an Argentinian flag. Once I have this and I train my model, it will automatically train a model on the cloud that I have some metrics here. This is very, and we can show this later if someone has questions on this interactive part. But here, once I train the model with these 60 images, I have a decent model, which I have a precision. It's one of the numbers that we use in machine learning, but almost 80%, which is kind of good. So I can start to use this. And the way to use this, I can train the model if I want here. I can upload custom pictures. And in example, I upload a picture of myself there, and it detected the Canada flag and the Argentinian flag. I upload one of the Ivana's pictures, detect the Argentina's one. So I have everything here. But the cool thing is that I can publish this model, and I will have an HTTP endpoint in the cloud that will allow me to, I can post a picture there, and then I will have a JSON result with the, I detected one flag, two flags, a Canada, Argentina, or whatever, everything there. I couldn't publish this online because I was basically killing my Azure subscription. I have this in one region, another region. But the cool thing about this is that you can also export this to use this in your model. And this is the moment that I realized, okay, I can do this something with my HoloLens. Because I know that in Windows 10, we can use Onyx model. So let me recap here. I train a model to detect flags, and one of the options is to use this on the cloud, so I can post an image in the cloud and get results. But another option is to download this model as a TensorFlow file, as an Onyx file, to use it locally. My choice, what is I really, really like, which is freaking awesome, we can do this. I say, okay, let's do this with Docker. You can export this as a Docker image, and you can run in your local machine, in a Raspberry Pi, or whatever you want, and it's going to work like a standard HTTP endpoint, but you have a different address. So once I have this, I basically export my image. This is the image that I have exported to detect the flags. I register and use this locally in my Docker machine. This is Portainer to see the Docker. And then I started to test this. So I can upload an image, and I will have a JSON result with, I detected the flag, this is an Argentinian flag or a Canada flag or whatever, basically in my local machine, the IP that I have, which is freaking amazing because the next step what I can do, I can create a crappy Python app, which is basically doing this, is hook up into my camera, and then starting to see what it recognizes. And you can see here in real time, it's working decent. I am not using my GPU, I'm only using the CPU to do this, but it's working between 2 and 3 frames per second to analyze, which is kind of cool. And it took me, I don't know, 150 lines of code. We are going to share all the code lines. So once I have this, then I go back to Unity. And I have a hate-love relation with Unity. Every time that they come here, I started to cry and to yell, then you want to help me. But I say, okay, one cool thing about Unity is basically, you know how to drag and create the scenes. You learn the basic here. But using the MRTK, it was not easy. We will tell you the details of what we learned here. But we can use this Docker container to analyze the camera view and start to do this. So I created a project. What you are going to see here, this is a video of a live project. And I'm not doing this live because I'm already using my camera for the stream. But what we have here is at the left, I have my Unity project with a couple of buttons and a label. At the right, you see my real and top right camera. I will analyze the frame, and I will change the flag detector label to see if I found an Argentina or a Canada flag. So get ready for a crappy demo / video, because what you are going to see here is that when I move, I started the project there, I will start here the analysis, and when I move myself covering and not covering the Canada flag, it will start to detect the Canada flag, and I will also show here the probability of the detection flag. I have Canada flag, 80%, 20%, or whatever. So it was very easy. I was happy to do this. I was able also to port this and use this very quickly in the HoloLens. So everything was amazing. But my goal for this was, okay, once I have this, my next step will be, let me go back here to my slide, okay, I know that the MRTK I can go and use the HoloLens 1 to another, but there is no Azure Kinect here, and I want to use in Azure Kinect. This is the moment I pick up the phone and I say, hey, Ivana, help me. So
yeah.
that's when we started to talk about it. This is my intro. How do we get here? So,
Yes.
Ivana, what's happened after that?
First of all, guys, in a moment, I will leave Bruno alone with a couple of slides because I will be showing my demo with my camera. So I will be leaving the meeting for a second and returning with the demo. So, so Bruno, please stay with the slides with me. Okay, so he contacted me and I say, wait a minute. The thing is, I have been working with Kinect. I have been working with MRTK, but I never had the challenge like Bruno proposed to me a couple of weeks ago to create a multi-platform application that could run both devices, not only on HoloLens 2, but also on Azure Kinect. But okay, this is a challenge that we accepted and we managed to try, we tried, guys, to come to this session with the most complex slash simple solution for this. And we had a lot of fundings in the way, which we have documented so you can see it. But well, check on next and start moving around. For you to know, guys, so a year ago, I started working with Azure Kinect. I never in my life worked with the sensor camera that had also the possibility to give me IR images, that had the possibility to get connected to the cloud, to computer vision, and analyze the image of what I was seeing through the camera. So I could do that simply through a webcam, but never had to analyze all the things that the Azure Kinect SDK provide for us to develop. So it was a challenge. As you can see in the demo, I managed to get the distance of my face to the camera in a simple WPF app. Okay, that's actually a Windows Universal app. Let's go to the next slide. Okay, so then I said, oh, these are the couple of things I had to learn. It was not easy, but as you can see, these are kind of the views that you can see on the Azure Kinect. You have the distance, you have the different views, you have different sensors. As you can see, you have microphones, you have accelerometers, you have gyroscope, and everything for you to code from behind. Which, if we think about it, if we think on HoloLens 2, and we know that the camera that the Azure Kinect has, I'm pointing at the camera because I'm streaming from an Azure Kinect, it's the same one that the HoloLens 2 has. So in my head, I said, okay, so this must be the same thing that actually HoloLens 2 uses. Okay, this is what it uses to identify my hands. This is what it uses to identify my head or my environment. Sorry. So next, come on, Bruno. Okay. Then I had the chance to meet Takashi Yoshinaga. So he is an MVP from mixed reality right now from Japan. So he explained to me how to manage to get the image of my Kinect through YouTube into a hologram. And that was a lot of work. And in the next slide, you will see that kind of work. Okay, I was exactly like that GIF, guys. It was a lot to learn, a lot to understand. I don't know. I think that the amount of mathematics, the amount of different image processing really made my head explode, because this is a terribly powerful device, but you need to code a lot in order to use it in depth as what it's actually built for. But I wanted to test and play around with holograms, and that's when I had the chance to get into MRTK. And in the next slide. So in here, you can see that I created one of my first POCs with MRTK, in which I managed to run the application, not in HoloLens, because I don't have HoloLens, but in iOS. So everything worked perfectly, and it was so easy, guys. You know, it was just drag and drop and coding some things on as code behind. So then I jumped into the scenario that Bruno was explaining, and I said, I have a secretary today. Okay. And I said, okay, guys, we have Universal Windows apps for Azure Kinect, and we have Universal Windows apps for HoloLens. So, Bruno, we can do it. We can do this. We have, I think it was a week and a half ago that we decided, and I said, let's do it. We can do it. And then something happened, which is, okay, that thing. Universal Windows Platform, red. However, there are limitations and requirements to this. And that's when all the journey, the funny journey with Bruno began. Okay? First of all, let's do it with Azure Kinect. No Azure Kinect for Unity. That was the first thing. No Azure Kinect for Unity. Why? Because it has a lot of dependency that Unity doesn't allow. So in order for me to use Azure Kinect with Unity, I had to kind of edit some of the classes that comes with the Azure Kinect, but I managed to do it. I managed to get it, the SDK running on Unity. We'll see it in a moment. But then I said, okay, I have all the code done for a couple of months last year, and that will work. Once I grab that script will work perfectly on Unity. And the next slide said the thing. What happened to that? And Bruno happened the same problem. Bruno?
Yes, that's basically Unity is amazing, but there is no, if you are a C# developer, and I am a C# developer, you get so used to NuGet, to package, to do a lot of things that when you go to a place that you can access your user tools, it blows your mind. It's basically said, okay, and there are no official SDKs for a lot of the community services for Unity. I know that, Ivana, you told me that there is one for the speech.
Yes, in fact, in one of the sessions that I give early, that I usually give online, we have a package, a Unity package with all the necessary plugins for speech cognitive services to run on MRTK, but that doesn't happen with computer or custom vision.
Yes, and at the end, it was basically silly because you think about that, hey, it's already C#, it's already there. I know that this is not C#, this is mono, so there is a lot of things to talk about here, but I don't know. Tell your experience there. I claim the HTTP one.
Okay, after that, I will leave, okay? So in here, so I just did that. I copied, pasted the code that worked perfectly on Visual Studio with the Universal Windows Platform, and as Bruno mentioned, with the Nugget package, and all these kind of things starting to appear. Okay, the type of namespace in Windows does not exist in the namespace Microsoft. What? Yes, Googled, search. No, it doesn't. And the next one shows the media that also does not exist in the namespace system that Windows. So yes, this was a problem because all the code that I had already built for Azure Kinect in Visual Studio running with Nugget packages, all this code worked perfectly, and I had to redo all the code. And I think it was a week and a half / I also work / I also have family. So we managed to run at least, I will show you in a couple of seconds. I managed to grab some things with the webcam and put some of the libraries in another side and put something with Kinect. I didn't have the entire scenario work yet, but I promise in the next session that Bruno and I are going to be showing the same topic that will be finished, because I will show it's a lot of work, a lot of image processing through code behind. So now I will leave you guys with Bruno's problems until I join back for the demo. 1 second, please.
Yes, the idea now is that because she's going to use the Kinect as the main source for the demo, she's going to reconnect. So we have her sharing the screen. And in the meantime, let me show you a couple of small details, the one that you lose a complete morning or a couple of days fixing. So an example, when I realized that there is no official SDK, I said, hey, no problem. Custom Vision, it's a Docker container, it's just an HTTP call. So if I can do an HTTP call in any language, I can basically post something and get back the data and analyze the JSON. So I find a couple of samples using the system.net HTTP client, which is an amazing library. I use the system.net client a lot, but somehow it didn't work on Unity. I don't know why. I basically faced that you can write the code is going to be compiled, but when it's working, it gets to the post to the line, and it gets freeze. As I said, I don't know the details. I know a couple of people suggest a couple of options. I really don't like these ugly solutions. What I found is that we can use one of the Unity libraries available to do this, which is the Unity web request, to make this. But the Unity web request was created initially with the idea to post forms request. So in order to make a simple post with an image, you need to find around, there is not a lot of documentation, and there is a lot of deprecated documentation, but you get to a point that you can do this. But again, you find that this is not an async await scenario. So you need to find a way to make a post. You are submitting images, depending on your network, it's going to be slow or fast process, but you need to do something like, I'm really sorry about this. There is a better way to do this. Also, you can implement here a counter and make some kind of timeout. But once you make the request, when you make the sender one request, you need to wait until it's processed. I did this eternal while in order to see if it's working. For a demo works, for a real environment, you need to apply a couple of best practices here to work. But HTTP client request is something that it requires a lot of saying, okay, how we are going to do this? It's very simple. I need to post an image and analyze the JSON. The second one was, okay, how we are going to work with the image. One of the default image formats is the BGRA32, which is supposed to be the good one. It's supposed to be the one that you can really, really use because it's going to have all of the pixels in a 4-byte format with the blue, green, red, and the alpha channel. So you can analyze this. Somehow, Custom Vision, the Python program who analyzes this, the Python Docker container, it doesn't like this. Lucky for us, you can change this to GPAG and it works. But again, it takes you a lot of time. I didn't put here any slides about what else we did around. Initially, I saved the images to a temporary file and then put it. I found a way that you can do this everything on the memory, which is kind of better and amazing. It works also very decent on the HoloLens, but every small detail that you're seeing that you are not going to face, like an example, HTTP client, pixel format, and these kind of things, it all requires a lot of dedication, and it all requires that you spend here a lot of time. So I hope that Ivana is back. So if we can join her and share her desktop, she's going to show how this works with all of this lesson learned in a common platform environment between Unity, the HoloLens, and the Azure Kinect. Ivana, are you back?
Can you hear me?
Yes, I can hear you.
Oh, perfect. So I think we have it working now. Let me share my screen. 1 second. Okay. So let me see please tell me when you see my screen. Okay, perfect. We are in. Great. So guys, as you can see, I'm moving my hands like if you guys are seeing me. Okay, so what I have in here is Unity, you guys know that. And I first said, okay, let's start simple because I had the opportunity to work with Unity and Azure Kinect. And as I mentioned earlier, in my experience, I had to code a lot in order to get the depth camera, to get all the things like I show you on the demos with my fellow MVP in Japan. But I said, I need something simple. I first need to see and test that I can run custom vision in my Unity application. And as you guys saw or heard during our session today, that's not by default. You cannot import the package and just run in here. And the other thing that we had the challenge was, actually we wanted, Bruno, you and I wanted to create an application that could detect flags, right? And something that happened to us is that the computer vision service does not detect Argentina flag. That was an issue, right? And that's why we had to use the custom vision situation. So we had to put our so Bruno had to run the model, and we created everything in Docker in order to detect the Argentina flag. So this was a specific scenario. We wanted the Argentina flag to be detected for this demo. And then then we had the challenge about how do we connect with let me open it. Hopefully this doesn't broke everything. This morning I had another session and it broke everything. Okay, perfect, it did it. So we had to connect to our local host, okay? So here I have a CS class in which I have my service URL and I have different information that I'm using in this code. So one of the items we used in order to manage everything without importing a package, without using something pre-built like a Nugget package, was, I think that Bruno mentioned it while I was not in here, we use also the Unity Engine Network to get the information from our local hosts. Okay, so what you're seeing in here is where the magic happens. So what we have is the Unity web request in which we provide the custom URL that we have that is going to return us if the Argentina flag or the Canadian flag is in here. And in my case, I analyzed the query and I detected, in this case, I do have an Argentina flag in here. If I had an Argentina flag, I would provide the result of what the local host is providing to me. Okay, so, and then I make a couple of things. So luckily, this will work out. I will explain what I have in my UI. So what I have is a canvas. As you can see in here, I don't have the mixed reality toolkit installed, but I have different elements that will create this application for me. I have an image that will represent the camera, that will load the camera that I'm using, and will have that information that I'm sending to Call Behance to be processed, and will receive the result of that information. Then I have a button which I will use in order to take a picture. I did not do the same demo that Bruno because I wanted to keep this simple. Then once you have the image, you can go to Call Behind and process it and return it or whatever you need. But in this case, I wanted to keep it simple for you guys to understand how easy it is to implement this. And then I have some information in here, and I made a small hologram that you're going to see there. So what you saw me drinking at the beginning of the session was a mate. That's a drink that we have in Argentina. And I'm so fan of drinking mate that I created a small 3D mate. So if the model detects that Argentina flag is in my environment, then it will load the hologram displaying the mate, because that's something that I can relate to in Argentina. Okay, so let's fingers crossed. If we run this, let's check it out. Yay, and here. Okay, so I loaded the camera, and I also have a panel in which I will receive the information that we have in our Docker. So basically, I just need to take a picture because I do have a flag in here, right? So there it goes, and that's it. That's what Bruno built, and that's the result that we are getting. It's detecting Argentina, and it's creating the predictions, and it's giving me the tag name Argentina in here. So basically what you can do, guys, oh, you are seeing me, I can move my hands. Okay, so what you're seeing on the demo, you can build a lot of things. So in this situation, since I moved some of the things, you can see this. We have a bounding box. So in Bruno's demo, he created a box in which he located the flag in the image that he was processing. In my case, the bounding box is in here. So with that information, I could put whatever thing I need to put on top of it. So let's move to a scenario in which we have a HoloLens and we are working on the street and suddenly we see, I don't know, the image. Of course, working with a HoloLens on the street, that would be the best scenario ever. But okay, guys. So if you're working on the street and you are seeing the image of, I don't know, Microsoft logo, suddenly things can appear from there because you are identifying and you are using cognitive services, okay? And that's the entire magic. This was the demo I had, but then I said, there has to be a way we can build this with MRTK. Okay, and what did I do? I came here, I installed the MRTK. I have exactly the same project that you saw earlier, but I installed MRTK. The only thing I did was to change the camera. So in here, I managed, in this case, and only in this sample, I put the webcam because it's detecting Azure Kinect as the webcam, okay? So if I run this with MRTK, let's go ahead and run this. Come on, Mr. Unity. You can do it. Live demo, guys. Live demos. Okay, so you guys can see me. Oh, yeah, you can see me. Okay, it's the same code and it's working with MRTK. Okay, so MRTK, all the buttons, all the things, everything is working with MRTK. Okay, my computer, you can see, guys, is in red. That's, and if we take the picture in here, would it work? Oh, magic, it did. So there was, I was breaking my head and saying, okay, MRTK does not allow this to work, won't allow this to work, but yes, I managed to put the same thing that Bruno did on custom vision on MRTK application running with Azure Kinect. In this case, I use it, as I said, as a webcam because I didn't want to put a lot of code and make you guys be mixed on the middle. But then I have another demo in here. Right now it has an error because I was testing some things, but I wanted to show you the amount of code that an application like this would take. So you can see in here, I have the plugins for the SDK for Azure Kinect. I do have them, but as I said, this is not 100% exactly like the one you install by Nugget package on Visual Studio. One of the things, for example, the memory of the images don't load exactly the same because it is not applied to our, one second, I want to show you a little bit of code. Okay, it doesn't apply to the same, okay, let me see, image processing, capture pixel. Okay, you can see there's a lot of processing of images processing, and we need to understand the difference and how to apply each one of them into our Unity. What's the difference between running this on Visual Studio and running this on Unity? I still don't have everything configured. I still don't know how to manage this exactly, but it's something that it's pending and we are planning with Bruno on doing it. So, but we still have it. We do have the MRTK running this. Okay, guys, that's it for my demo. Bruno, all yours. I will join with camera.
Okay, can we switch back to my desktop? Perfect.
Yes, sir.
So while Ivana is joining back, let me do a quick recap. As you can see, it's amazing, it's working. Sorry about that, but I drag Ivana into this path. I really love this meme because when I see this meme and I see the movie is amazing. This is basically me. Someone asking the question if we're going to share the code, and yes, we're going to share the code in the repo. probably in my blog tomorrow, or also in Ivana. So we are going to share everything here. But before going back, and I am waiting for Ivana, let me recap a little about what we found. So there are no official SDKs for a lot of things in Unity. And again, this is me going back to Unity from time to time. So when there is no official SDK, but the core is as simple as an HTTP request, we can create and do our custom code. It should be easier. It's very, very easy. And okay, I see in one of the comments that the HTTP client usually works, but does not work when it's pulled a lot. This is real-time cameras, frame-by-frame video, so it's really heavy. The Unity works. I'm guessing that with all of the things starting to get more mature, we are going to have something there which is really going to be amazing. But connecting the dots and testing your patient, we are going to, things can happen. And basically, we start to think where we want to use this. Why do you want to have this? We didn't do the bounding box here. We just analyze and detect something. The next step will be to draw the frame around the detected object. But because we are using the Kinect or the HoloLens, we also may know the distance for the object. So we can do other scenarios like, hey, I detect this and I know that it's there. We can do some analysis. There is a lot of business scenario. We can even correlate this. Let me start with,
also, Bruno, not only you can detect the distance to object, but you have the body tracking in Azure Kinect, and you can detect the hand gestures, you can detect the face, different parts of the face. So it's in order, just the perfect scenario would be if we could create a hologram in which you can interact with the hologram and the HoloLens too, and I can also interact with the same hologram, but with Azure Kinect. Of course, we are talking about also including Azure Special Anchors and all the necessary things in order for the holograms to understand where he is and how to execute from our events, from our gestures. But I think that would be the best great idea that could be the possible next scenario.
Yes, the one that they want to finish with the Azure Kinect is also using the thermal camera. So you see there is a thermal camera that I have somewhere here. This is an iced coffee. So you see when I move the iced coffee, how is it different? I don't know why my head is, I am not very smart. I am not using a lot of temperature in my head. My head is also cold. But this is something else that we can start to collect and put the data there. And again, we can do this all mixing between the data feed from a Kinect or a HoloLens plus other scenarios. This is something amazing that we can start to do. So let me go back here. I think we kill it in terms of time. I don't know if we have some questions here or I forget anything else, Ivana, that I missed?
No, the only thing is that I trust the mixed reality team is working on updating all the packages for consuming the cognitive services in MRTK. This MRTK was launched, I think it was a month or 2 months ago. So I would be sure that in the next couple of months there will be any updates on this. So that's it.
Yes, and just to double check, we are working with, I think it's 2.04.
2.40.
2.40, yes. So just double checking that that's the version that we have. And hey, it's a nice try to learn and to build cool things.
Hello, Bruno.
Hey, Aram, how are you?
Great. You guys did an amazing job, I must say.
Thank you very much. Ivana rocks. She's amazing. I'm just here to
yeah.
The minimum.
So I have some questions, right? Also, I think there's some questions from the comment. Okay. So I have some questions. My first question is, how did you guys stay focused?
It's hard. I mean, when we started to do this, it was kind of an internal challenge for us because the HoloLens, she had the Kinect. We tried to figure out if there is a common place. Sure that it was a common place, but as you see, we learn a lot in the process. There is no common place. There is a lot of more strict that you need to do. Something as silly as handle the HTTP client calls in a different way can change the way that you approach this, but at the end, it's all about processing images and trying to have this extra feature from the HoloLens and the Azure Kinect. So we managed to get to a point that everything was working.
Amazing. And I guess you guys had fun all the way.
Yes, we also had a lot of fun. As I said, that was kind of our main idea, to do something that we can use later, learn, and it was a fun sharing process.
Great, great. Also, what are the necessary skills required to develop for Azure Kinect?
So the Azure Kinect, I'm not an expert, but as far as I remember, there is SDK, and it's available for different sets of languages. So if you are in the Microsoft stack, if you know the Microsoft language and the Microsoft everything there, you just need to read and implement this SDK. The nice things about this is that you can use the Kinect just as a camera. So you can access frame by frame. You can access different type of cameras, so the color camera, the infrared camera, and all of these. And you can also access features specific to Kinect, like measuring distance, detecting bodies, or you can mix everything there. So you can start from standard developer to do the Kinect stuff, and then you can go deep to also access these features there.
Right. I guess it's a very long journey. Okay.
Yes.
I was really amazed about Ivana's projects in regards HoloLens. I mean, in regards hologram, and I believe like the hologram is the next big thing, right? So what's the relationship between the HoloLens and also the hologram?
So yes, the HoloLens and the Kinect have these special cameras, which is basically not only give you information around the 2D camera, the RGB camera, also give you the sense of depth. When we have the depth, when we have the distance on each one of the pixels plus the camera, we can start to create 3D models for our environment. And because we also have the motion sensors, we can in real time see when we are moving. We can start to create this idea of what is around. So I am moving my camera, I am analyzing the frames, I am moving the Kinect and analyzing the frames, and I get a sense of the 3D environment around me. With all of that, I can do a couple of things. First, I can understand my environment. And then if I want, using an example, the HoloLens, I can project a hologram in front of me, which is going to be probably adapted to my environment. So I can put, I don't know, an animal on a table, or I can put something flying around. And the idea of the hologram is that in the same way that we move the device and we analyze each one of the frames around us, we can move the device and keep the hologram in the same place because we know how the device is moving. So with all of this information at the same time, we can get there. It's an extra layer of information. It's basically augmenting what are you doing. You can see a device and you can see you can see something, like an example is here a microphone, and you can see information all around the microphone. How should I use the microphone? What is the model? What is this button for, or whatever? As you say, it's going to be the next one. It's going to be the very important one, and it's all around now. We can take advantage of that, but it's a learning process because it's not just 2D programming. You need to learn about 3D, how these things are moving. Lucky for us, the SDK give us a high level abstraction on top of that, so we don't need to deal with pins and coordinates and whatever. We put a hologram, and the hologram is there.
Amazing. My last question: how can we connect with what you guys are currently building? Do you have a blog, Medium page?
Twitter, it's El Bruno. You have it in my name there.
Okay.
I also have a blog which is elbruno.com. It's the same as my twitter.com. And her Twitter is her name is Ivana Tilka. And she also has a blog, but I can't remember the blog. I will post it later, her blog address. I can't remember her blog address. And yes, everything that we do, we share there. We're probably going to share the code and the samples today or tomorrow for this session in our blog and in Twitter. And happy to help in everything that we can.
Great. I'll be watching and I'm also engaging. So thank you
Perfect.
so much. Thank you so much to Ivana for also jumping in. I appreciate your time.
Okay, perfect, Harold. A pleasure. See you next one.
Yeah, thank you. Bye bye. So thank you everyone. It's a wrap, and super excited about the Global XR Bootcamp and everyone that participated. Thank you so much. Thank you to the team. Thank you to the moderators, the speakers, and I wish you all the very best ahead. Stay safe. Bye.